Hi, welcome back. And this time I'm going to explain about interface inside object-oriented programming language interface. So, what is an interface and the meaning of interface inside object-oriented programming language? So, interface generally it's a construct. It's a contract. It is stating it's a contract stating how classes should interact with one another, and it can be used. You can use some classes. Okay, you can use some classes without knowing how it was implemented. As long as you know the interface it's this class implements. What is a class implementation of an interface? I'm gonna tell right after this a little bit. So, um, so this one, what is the meaning of this? So you can use some classes without knowing how it was implemented. As long as you know the interface, that's why you can just learn the interface, and later on, you can use many different classes, okay, as long as they implement that interface, okay, as long as the as long as okay as long as just classes implement this interface. So what is the meaning of this one? So it's for flexibility. Why flexibility? Because you can change of your class implementation. You can change class implementations. Okay, but if you do know the interface, you can still use the same thing. It's for extensibility. Why? Because you can add more classes, have more different or new classes added to the system as long as they are containing the same interface. Then it's going to be usable. Okay, then inside most programming languages, okay, interface is a place which contains all of the method signature for some classes. So what does that mean? A method signature here, it's a method declarations, okay, method declarations, but without definitions. What does that means? Method declaration with the method definition without definition. This one means there is the there is declarations, but no implementations. Okay, what does that mean? No implementation, nobody there. Okay, means something like this. If you have an add method, you're just gonna declare int add int x int y, and then you end the statement. There is no such thing like int add, okay, int x int y. This one is going to return x plus y. If this one, there is an implementation of the complete methods already. This is a complete implementation of the method already, but in this case interface, you will only declare it. Okay, you will only declare the method signatures without definitions. Okay, this one is the method definition already, and this one actually it is the responsibility of the class. Okay, some class need to implement these methods. Okay, some classes need to implement these methods. Okay, then it rarely happens, and also depends on your programming languages. It's sometimes it's rarely contains some further information, also depending on your programming languages, whether it's C++ or Java or C#. It may contain some constants. Okay, it may contain some static methods. It may contain something like default methods. It may contain some nested type. means other classes within it, defined within the interface. Okay. Other classes defined within the interface. Working with the interface is having some special point. You cannot instantiate interface. Why can't you instantiate interface? The reason is inside there it only contains the declaration of the methods. It tells what method it is there. Okay, so it's that's why it, how to say, cannot be used directly. Okay, however, it can be implemented. What does that mean? Can be implemented. It can be given the body of. This one means given or define the body of the methods, which was declared in the interface. Okay, let's just give a simple example. I'm going to declare an interface iMath. Okay, this one is iMath, iMathematics. Then inside that interface, I'm going to, this one I'm going to say it's an interface inside. I'm using pseudocode here. It's not any specific programming languages. During the demonstration, I want to show you the corresponding code in corresponding programming languages. So this one, let's say I'm going to declare an interface, which is the interface for the method add. Okay. You don't have to say it public, because anyway the interface is for other people to use, so it's always public. So let's say add in x int y. This one is an interface, and you'll say that if in my interface I'm defining an interface called iMath, and I'm declaring that I'm declaring inside this interface that is one method, and any class which claims, let's say we're going to have a class myMath there, and this one claims to implements. If this myMath claims to implement the interface iMath, again this one is not any specific programming languages. I'm using pseudo programming languages because the syntax might be different a little bit from Java to C# or others, but I will explain about that later. And then inside here, interface iMath, and we're going to declare a method which is to be able to add two numbers, and this myMath class is implements the interface iMath. If it implements the interface iMath, then this class should give the definition for this add methods. So it's gonna be like int. So this one should have the int return type int. Okay, add int x int y, but it's not just a definition declaration anymore. It needs to give the body definition of this one, which is result returning int g equal to x plus y, and then you're going to return g. This one is the class implementation. And then other classes, you may have other classes as well, YourMath, let's say, and if it's also claiming to implement iMath, then it must also to give the definition of int add, int x, int y. Okay. But you may do different implementation of this one. Let's say you're going to do return x plus y. Okay, it looks like a different, just to show, it looks like different implementation, but actually it's the same thing. But you know, it's just to show that this one you are able to keep different definition of this one, and we can use both of these YourMath or myMath classes as long as you do know that they implement iMath, because both of them are gonna have the add methods, and the add method gonna work this way. Okay, so this one is the meaning of this one is the meaning of interfaces. That's why you can just get back to this one. You can see it is a contract stating how classes interact. So it's iMath is a contract stating how do we work with myMath and YourMath. Okay, because they both have the add methods of the same way. This way, as long as we put two input integers, and it's gonna return us the one integer as integer as a result. Okay, so you don't know whether it's myMath or YourMath or whatever math, as long as it claims that it's going to implement it's implemented the iMath interface, then you can use the add method sys, like from the iMath interface. So you can use any classes without knowing the implementation, whether it's implemented this way or it's implemented this way. We don't care about it. You can just learn the interface. Okay, you just learn this interface and you know to use other classes here. So it's for flexibility, for extensibility. Flexibility is going to use MyMath, or you can use YourMath. It's also okay. For extensibility, is going to add any other class, okay, like whoever math in there, and you need to implement that iMath. Then you do the new implementations here, okay, in X, int, Y, okay. Then you're doing the new implementation here, okay. Then it won't work. Okay, that one is the meaning of what interface is, and I'm going to go show you some different implementation or different demonstration right after this.